Everyone, we are talking about sum and difference properties of trigonometric functions. So first we're going to start with a review of even and odd. So if you remember from back with functions, if we plug in a negative x, we receive the exact same function back. Then this is an example of an even function. Okay, if we plug in negative x, we receive the exact opposite function back. That's how we prove that this function is odd. So if they ask which trig functions are even and odd, you can go through this process to prove that, but I know that the even functions are cosine and secant. The odd functions are going to be sine, cosecant, tangent, and cotangent. Kind of makes sense when you think about these because you are dividing an odd function by an even function or an even function by an odd function. It ends up turning the whole thing odd. That won't always happen, but in this case it does. And again, you can go through this process to prove that yourself. Okay, in terms of talking about co-function properties, okay, the co in co-function is going to stand for complement. So we're thinking about complementary functions. So when we ask what the complement of 36 is, remember that we're talking about two numbers that add to make 90. Okay, so this case will be 54. So when I'm talking about the cofunction property, typically that relates to here is sine and cosine, where sine of 36 is equal to cosine of 54. So if I plug in the complement or two complementary numbers into each of these functions, you'll end up getting the same answer. And you can check that in your calculator if you want. Makes a lot of sense, and it corresponds a little bit with the unit circle in terms of the fact that your 60-degree angle and your 30-degree angle that's a really bad right triangle, but bear with me. There's a little bit of symmetry in terms of these points, how it's the exact same triangle but just flipped a little bit. That's not what I meant to do. And okay, things are happening. And so because of that, it's not because of this, but it's just a really easy way to see this in the unit circle. If I plug in a number into sine and the complement into cosine, you'll end up getting the same answer. So sine of 20 is equivalent to cosine of 70. 70 degrees. Okay. So again, you can check this in your calculator. The cofunction of tangent, as you could guess, is cotangent. And the cofunction of secant is, you guessed it, cosecant. Okay, so the names make it really easy for us to remember what's what. Now, in terms of writing out mathematically, this is what we're looking at. And if you've seen this before, usually you might see this just to show that sine and cosine are essentially the same function, just translated. Okay, so flipped and translated. And that's really the case for every single other function and their reciprocal. Secant and cosecant. Sorry, not reciprocal, their complement. Every function is just the same as their complementary function, just flipped and shifted. Okay, so that's how those work. So for example, if I ask you the equivalent to cosecant of 35, then I know that I'm going to use secant, and the complement of 35 is 55. Right, same thing here. So I'm working with tangent, so I know that the complement of tangent is cotangent. The complement of 15 is 75. Okay, so actually going to the sum and difference property, first let's just prove that this is incorrect. Okay, now obviously we know that this isn't true because of PEMDAS, or order of operations. Okay, but let's go ahead and prove this. And to disprove a property, you only need to show one example of it not working. So if we let A be 30 and B be 90, cosine of A plus B is going to be cosine of 120 degrees. Okay, so in that case, cosine of 120 degrees is 1/2. Here, if I, again, plug in 30 and 90, I get cosine of 30 plus cosine of 90. Cosine of 30 is root 3 over 2. Cosine of 90 is 0. I end up with not matching answers. Okay, so now I know that this is not true. You have to do the parentheses first before. You cannot distribute the cosine. It doesn't work like that. We're not multiplying cosine to a and b. Cosine is a function in and of itself. It's not multiplication, and so you can't do that. Now that leads us to the idea of the sum and difference properties, which I'll write for you right here. So I know that sine of, I'll use a and b, so a plus or minus b is sine of a cosine of b plus or minus cosine of a sine of b. Okay, for the cosine property, it's almost the same thing, but a little bit tricky with the negatives, so it's a plus or minus b. We end up with cosine of a times cosine of b minus plus sine of a sine of b. So all I mean by that is if you have a plus sign on the inside of your cosine function, then these two quantities will have a subtraction sign in between them. Okay, so these are what are known as the sum and difference properties for my trigonometric functions. So if I'm asked to simplify this expression using my sum and difference properties, I'm just looking at my two angles here. So I'm going to say that 34 is A and 20 is B. I see I have cosine times cosine plus sine times sine. So I know that this is the same thing as cosine of 34 and 20. I have a plus sign here that corresponds with a minus sign. Okay, so this would be the same thing as cosine of 14 degrees. Okay, so cosine of 14 is equivalent to cosine of 34 minus 20, which is equivalent to all of this stuff. Okay, that's how we use our sum and difference properties. Alright, so let's move on. So then they asked me to prove using my sum and difference properties. So let's go ahead and prove that. Okay, so in this case, I will call x a and pi b. Okay, so I know that cosine of a minus b will be cosine of x times cosine of b, in this case pi, plus sine of a times sine of b. Okay, let's simplify this just a little bit. So I know that cosine of pi is -1, so I'll have a negative cosine of x. I know that sine of pi is 0, so 0. And I got to my goal, so I have completed my proof. Alright, next example, I'm going to do the exact same thing. So I'll label my functions a and b respectively. Okay, so next example, I'm not going to use that. I can just straight up use my cofunction properties. So I know if I scroll up, I can use this property right here. Okay, so cosecant is secant of 90 minus theta. So I'll go back down to my problem. But instead of 90 minus theta, I have theta minus 90. Right, but that's okay. So I will introduce a negative here to get my 90 minus theta. Okay. Now we can use my even-odd property here. So I know that cosecant is an example of an odd function. So if I plug in a negative, I get a negative in return. Okay, so I can take the negative out. 90 minus theta. And cosecant of 90 minus theta is, as we just saw, the same thing as secant. and so I end up with negative secant equal to negative secant. So I've completed my proof. Right, so I had to use both my cofunction property and my even odd property. Right, so that's it for these notes. I will see you all later.